Hello everyone. You know the drill here. We're going to do the next question in the March Leetcode challenge. Um, so this one is a very interesting one. It seems hard from first look. So basically the question here is, can you rearrange these numbers so then it's a number that is a power of 2, meaning 16 is already itself a power of 2. 46 by itself is not, but if you rearrange it to 64, it becomes a power of 2, right? So it seems like it's a permutation issue, but after thinking about it a little bit more, it's actually like comparing an anagram. And we have a standard algorithm for comparing an anagram, right? So if you don't know that, just go YouTube it. It's pretty standard. So basically what happens, what we're going to do then is we see that the constraint is 10 to the power of 9. It seems like it's a lot. Honestly, even linear time won't go 10 billion, but what we can do is just iterate through the ones that are power of 2. So how do you get to the power of 2? So if we say like 2 to the 30, I already typed it in, that's already around 1 billion, right? And so all we need to do is iterate from 2 to the power of 30, range to 2 to the 31, right? And then raise that to the power of 2, 2 to the power, raise that, then we can compare the anagrams of those numbers with what we're looking for, right? Let me show you what I mean. So let's say we have a function called, so for I in range all the way up to the 31, right? Let's say we have a function called if is or let's convert them into string first. So the first string is the 2 to the power of the I. So this represents the numbers that are to the power of I from 0 to 31. So covering all 9 billion. 1 billion. So here, let's also convert the n into a string. So let's say we have a function called check anagram. This check anagram will simply check that the strings have the same, are basically anagrams of each other. So if that is true, then you return true. Return false here. Now we use our standard anagram checking algorithm. Check anagram AB. First, we collect the mapping of the string. So let's say MA equals collect self dot collect mappings of A. MB is equal to self dot collect mappings of B. If let's say, well, there's a few things we know it's not an anagram. If any of the keys in the A is not in B, then we know it's not an anagram. So let's get all the keys in A. A.keys. If for key in keys, if key not in MB, then we know it's not an anagram. Else, we also know it's not an anagram if the number of items in that, the number of characters don't match. So if MA key doesn't equal MB key, then we know that it doesn't match. If all of this checks out, then we know that it's true. Now we need to implement that collect mappings function. So self, this is pretty standard. Collect mappings self some string s. So m equals this for c and s. If you've seen it already, then you simply say MC increment to 1. If you haven't seen it yet, then you add 1. You initialize 1, I mean. And return M. Hopefully I didn't make a silly mistake there. Let's try out different test cases for sanity, because true or false is always one of those things that are tricky, because you don't know whether you just, because it's 50-50, right? You don't know whether you just got it right by accident or not. So we'll see. Okay, I did just get it right by accident. So what went wrong there? I am returning keys here. Let me check the mapping of 24. Interesting. That should have just returned. Oh, that's MB. And it had I'm also not, the number of values of A should also be the same as the number of values in B. So the keys of B should also be the same. Okay, let's try out all the other ones again. 1046. 24, I already have it. 218, that should be true. Okay, let's see. Yep. So yeah, so it's a pretty simple problem. And hopefully that makes a lot of sense. So yeah, next time.